I've been a systems integration specialist for offshore drilling platforms for 17 years now, and in that time I've learned one fundamental truth about the oil and gas industry. The people who understand the technology are rarely the ones making decisions about it. And the people making decisions about it rarely understand the first thing about keeping a drilling operation running safely 200 miles from the nearest coastline. My name doesn't matter for this story, but my job title does. I'm what the industry calls a SCADA engineer, which stands for Supervisory Control and Data Acquisition, and my entire career has been dedicated to making sure that the incredibly complex network of sensors, controllers, programmable logic units, and communication systems that keep an offshore platform operational don't suddenly decide to fail in spectacular and potentially lethal ways. I started working for Marine Petroleum back in 2007, fresh out of a computer engineering program at Texas A&M with a specialization in industrial control systems. Back then, Meridian was a mid-sized independent operator with about a dozen platforms scattered across the Gulf of Mexico, and they had a reputation for doing things the right way. They invested in their equipment, they maintained their infrastructure, and most importantly, they understood that the technology running their operations wasn't something you could cheap out on without eventually paying a catastrophic price. I cut my teeth on their older platforms, the ones running legacy systems that required someone who could speak both modern network protocols and the ancient languages of industrial automation that dated back to the 1980s. I became the guy they called when a platform's control system started acting strange, when communication links dropped unexpectedly, or when the dozens of interconnected subsystems that managed everything from blowout preventers to fire suppression needed to be upgraded without taking the entire operation offline. By 2019, I had worked my way up to senior systems architect, and my primary responsibility was the Esperanza platform, a semi-submersible drilling rig positioned about 190 miles southeast of Brownsville, Texas, right at the edge of Mexican territorial waters in the Gulf. The Esperanza was a beast of engineering, capable of drilling in water depths exceeding 8,000 feet, and her control systems were my masterpiece. Over the course of 3 years, I had personally overseen the complete modernization of her SCADA infrastructure, replacing aging Honeywell controllers with a redundant network of Allen Bradley control logic systems, implementing a fiber optic backbone that eliminated the electromagnetic interference issues that had plagued the previous copper-based network, and designing a custom human-machine interface that gave the drilling crew real-time visibility into every critical parameter from mud weight to riser tension to the 17 different pressure readings that together painted a picture of Lupin miles below the ocean floor. I knew every cable run, every network switch, every PLC rack, and every sensor node on that platform. I had personally written or reviewed every line of ladder logic controlling the critical safety systems. I had spent countless nights sleeping in a cramped cabin on the platform while waiting for maintenance windows to test failover procedures. The Esperanza wasn't just a job to me, she was a testament to what proper engineering looked like when management actually listened to the technical experts and gave them the resources to do things correctly. And then, in March of 2023, everything changed. Meridian Petroleum was acquired by a private equity consortium called Blackshore Capital Partners, and within 60 days, the entire management structure of the company was gutted and rebuilt with people who had no background in oil and gas operations whatsoever. The new chief operating officer came from a logistics company. The new VP of technology came from a retail chain, and the new regional operations manager for the Gulf Mexico division, the person who would become my direct supervisor, and the architect of everything that followed, was a 34-year MBA graduate named Preston Holcomb, who had previously spent his career optimizing warehouse operations for an e-commerce fulfillment company. I remember the first time I met Preston with perfect clarity. because it was the moment I realized that 17 years of hard-earned expertise were about to become worthless in the eyes of the people signing my paychecks. He arrived on the Esperanza via helicopter on a Tuesday morning in late April, wearing a brand new Meridian branded hard hat that still had the price sticker residue on the brim and a pair of what I can only describe as designer steel-toed boots that had clearly never touched an actual work surface before that day. He was tall, athletic in that CrossFit and protein shakes way, with the kind of aggressively confident smile that told you he'd never encountered a problem he couldn't solve by firing enough people. "You must be the IT guy," he said, when we were introduced in the platform's control room, and I felt my jaw tighten at the casual dismissal embedded in those 5 words. IT guy, as if the sophisticated industrial control systems I maintained were somehow equivalent to resetting passwords and unjamming printers. I explained, as patiently as I could manage, that I was the SCADA systems architect responsible for the platform's entire operational technology infrastructure, and I watched his eyes glaze over about 4 seconds into my explanation. Right? He interrupted, waving his hand in a gesture that suggested my job description was an irrelevant detail. "Computer stuff. Got it. Listen, I've been reviewing the operational budgets for this platform, and there are some serious inefficiencies we need to address. Corporate wants a 20% reduction in non-essential personnel costs by Q3, and I'm seeing a lot of overlap in the technical support functions. You have 4 people on your team, correct?" I confirmed that yes, I had 4 people on my systems team myself, 2 field technicians who handled the day-to-day maintenance of the sensor networks and communication equipment, and a junior engineer I was training to eventually take over some of the PLC programming responsibilities. I explained that this was actually a lean operation for a platform of the Esperanza's complexity, that the industry standard would call for at least 6 dedicated personnel, and that the reason we functioned effectively with 4 was because all of us had extensive cross-training and worked an average of 55 hours per week. Preston nodded along, and I could see him doing math in his head, the kind of math that reduced human expertise to line items on a spreadsheet. "Here's what I'm thinking," he said, pulling out his phone and showing me a screenshot of what appeared to be a contractor listing from some offshore services marketplace I'd never heard of. "I've found a company that can provide remote monitoring and system support for offshore platforms at a fraction of what we're currently paying for your on-site team. They use AI-driven predictive analytics to identify issues before they become problems, and they can handle everything through a centralized operations center in Manila. They're estimating they can replace your entire function for about $40,000 a month, which is less than half of what your team costs fully loaded with benefits and rotation expenses." I stared at the phone screen, trying to process what I was hearing. The company he was showing me, something called Ocean Tech Solutions, had a website that looked like it had been built using a free template, with stock photos of control rooms that I immediately recognized as belonging to completely different industries. One of the images was clearly from a power plant in Europe. Another appeared to be from a water treatment facility. There was nothing in their marketing materials suggesting any actual experience with offshore drilling operations, SCADA systems, or the specific regulatory requirements that govern safety, critical infrastructure on platforms operating in US and Mexican waters. "Preston," I said, measuring my words carefully, because I could already sense that direct confrontation would get me nowhere. "I appreciate that you're looking for cost efficiencies. But what you're describing isn't really possible. Remote monitoring can supplement on-site personnel, but it can't replace them. These systems require hands-on maintenance. When a fiber splice goes bad, someone has to physically locate it and repair it. When a controller faults, someone has to pull the cards and diagnose the failure mode. When we need to make changes to the safety logic, those changes have to be tested in a controlled environment, by someone who understands the specific configuration of this platform. You can't do that from Manila. He smiled at me with the patient condescension of someone who believed they understood things. I was too mired in my own expertise to see clearly. That's exactly the kind of thinking that creates cost bloat, he said. You've been doing things a certain way for so long that you can't imagine doing them differently. But technology has evolved. These remote operations centers are managing platforms all over the world. They have AI that can predict failures before they happen. They don't need someone physically on site, because they're smarter about how they approach the problem. I tried a different approach. I explained the regulatory framework, the fact that the Bureau of Safety and Environmental Enforcement had specific requirements for on-site technical personnel, that our operating permits in Mexican waters had similar stipulations, that the insurance policies covering the platform would almost certainly require review if we eliminated the systems team. Preston listened to about 30 seconds of this before cutting me off. I've already discussed the regulatory concerns with our legal team, and they're confident we can navigate any permit modifications. The insurance question is being handled by risk management. What I need from you is cooperation, not obstacles. I'm giving you until the end of May to document your systems thoroughly enough that OceanTech can take over remote monitoring responsibilities. Your 2 technicians will be transitioned off the platform at that time. You and your junior engineer can stay on through June to handle the knowledge transfer, and then we'll evaluate whether there's an ongoing need for any on-site technical presence. I felt something cold settle in my stomach. As I realized he wasn't asking for my input, he was informing me of a decision that had already been made, probably weeks ago, probably before he ever set foot on the platform. Everything about this visit, the introduction, the budget discussion, the presentation of OceanTech as a solution, had been theatrical. He wanted documentation that he could point to later showing that the transition had been handled professionally, that the technical expert had been consulted, that proper procedures had been followed. He didn't want my expertise. He wanted my compliance. Preston, I said, one final attempt. What you're describing is going to get people killed. I'm not being dramatic. I'm not being territorial about my job. I'm telling you, as someone who has spent nearly 2 decades keeping platforms like this one running safely, that what you're proposing creates unacceptable risk. These systems fail. They fail regularly. And when they fail, you need someone who knows this specific platform, who can respond in minutes, not someone in a call center halfway around the world who has to figure out which manual to reference. He patted me on the shoulder, a gesture so dismissive that I had to actively resist the urge to step away from him. I hear your concerns, and they're noted, but this decision has been made at levels above both of us, and our job now is execution. I'll need that documentation started by Monday. Make sure it's thorough. OceanTech's transition team will be reviewing it remotely before they come on site for the handover. He walked out of the control room, already typing something into his phone, and I stood there watching the banks of monitors that displayed the real-time status of every critical system on the Esperanza. Somewhere 5 miles beneath my feet, the drill string was slowly rotating through geological formations that hadn't been disturbed in millions of years, kept in check by a delicate balance of pressure, chemistry, and equipment that required constant vigilance to maintain. And the person now responsible for overseeing that operation had just compared my job to warehouse logistics and decided that a chatbot in Manila could do it better. That night, I started writing emails. I documented every concern I had in excruciating technical detail. I sent copies to the drilling superintendent, the platform manager, the safety officer, and the environmental compliance coordinator. I created a paper trail so thorough that no one would ever be able to claim they hadn't been warned. I saved copies of everything to my personal email, to a thumb drive, and to a cloud backup, because I had been in this industry long enough to know that when disasters happened, the first thing that disappeared was evidence of who had raised concerns beforehand. By the middle of May, my 2 technicians had received their termination notices. By the end of May, I had produced over 300 pages of system documentation, which I knew would be useless to anyone who didn't already understand the underlying architecture. By the first week of June, OceanTech Solutions had taken over remote monitoring responsibilities, and I was fielding calls at 3 in the morning from technicians in Manila who couldn't figure out why certain alarms were triggering or what the appropriate response procedures were. And then, on June 19th, the night the storm came through, everything I had warned them about started to happen. The storm itself wasn't anything unusual for June in the Gulf of Mexico. Tropical depression systems roll through that region constantly during hurricane season, and the Esperanza was built to withstand far worse than the 40-knot winds and 12-foot swells that the Weather Service was predicting for that particular Thursday evening. I had weathered dozens of similar systems on various platforms over the years, and under normal circumstances, a storm like this would have been nothing more than an uncomfortable night of pitching and rolling followed by a morning of inspecting equipment for any water intrusion or physical damage. But circumstances on the Esperanza were no longer normal, and the storm became the catalyst that transformed Preston Holcomb's cost-cutting initiative from a theoretical disaster waiting to happen into an actual catastrophe, unfolding in real time. I should mention that by June 19th, I was no longer technically an employee of Meridian Petroleum. My termination had come through on June 15th, 4 days earlier, with a separation agreement that included a modest severance package and a non-disparagement clause that I refused to sign. Preston had personally delivered the news, explaining that my resistance to organizational change and failure to embrace innovative operational models had made my continued employment untenable. He thanked me for my years of service and informed me that a helicopter would be arriving the following morning to transport me back to the mainland. I asked him who would be responsible for the platform's control systems once I was gone, and he told me that OceanTech had everything under control and that my junior engineer, a 26-year-old named Marcus Chen, who had been on the job for less than 18 months, would serve as the on-site liaison for any issues requiring physical intervention. Marcus was a good kid with genuine talent, but he wasn't ready. I had been training him methodically, building his knowledge base systematically the way my own mentor had done for me years earlier, and I had estimated he needed at least another 2 years before he would be capable of handling complex troubleshooting scenarios independently. When I told him I was being let go, his face went pale, and he asked me what he was supposed to do if something went seriously wrong. I spent my last 12 hours on the platform, walking him through emergency procedures, showing him where I kept my personal notes on system quirks that weren't documented anywhere official, and making him promise to call my personal cell phone if anything happened that he couldn't handle. It was against company policy, of course. I was supposed to sever all contact with platform operations upon termination. But I knew Marcus, and I knew the Esperanza, and I wasn't about to let either of them suffer, because Preston Holcomb couldn't tell the difference between a SCADA network and a Wi-Fi router. So when my phone rang at 11:47 on the night of June 19th, 4 days after I had been unceremoniously removed from the platform and deposited at the Meridian Shore Base in Port Isabel, Texas, I was expecting it. What I wasn't expecting was the raw panic in Marcus's voice. "The fiber trunk is down," he said, speaking so fast that the words almost blurred together. "The main fiber trunk between the control room and the drill floor instrumentation. I'm showing complete loss of signal on 17 sensor nodes, including the mud weight monitors, the standpipe pressure transducers, and 3 of the BOP status indicators. I called OceanTech, and they kept asking me to restart the network switches, but the switches are fine. I already checked. It's a physical layer problem somewhere run and I don't know where to start looking because the storm has the deck conditions at like category yellow and I'm not hematraces in this weather without a safety observer, but there's no way I observe and the driller is asking me why his pressing readings me, why his pressure reading are frozen and I know what to tell him. I sat up in my hotel bed. Now I know what to tell bed. Suddenly completely awake, my mind already racing through the implications of what he was describing. The fiber trunk he was referring to was a critical communication pathway that carried data from dozens of sensors located in and around the drill floor to the main control system in the platform's operations center. Without those sensors providing real-time data, the drilling crew was essentially operating blind. They could see what was happening at the surface, but they had no visibility into the downhole conditions that were essential for maintaining well control. Mud weight, standpipe pressure, flow rates, BOP status indicators. These weren't optional data points. These were the readings that told you whether you were about to experience a kick, which is the industry term for an uncontrolled influx of formation fluids into the wellbore, which is the precursor to a blowout, which is the scenario that keeps every drilling engineer awake at night. I asked Marcus what the drilling superintendent was doing, and he told me that the superintendent, a veteran named Carlos Mendez, who had been with Meridian for over 20 years, was on the phone with the Ocean Tech Operations Center, trying to get someone who understood what was happening. I asked if Carlos had made the decision to suspend drilling operations until the sensor issue was resolved, and Marcus said that Carlos wanted to, but that Preston Holcomb, who was apparently still on the platform conducting some kind of extended operational review, had overruled him and ordered drilling to continue at reduced speed while the technical difficulties were being addressed. I felt my blood pressure spike at that information. Continuing to drill without accurate pressure monitoring during a storm that was causing the platform to pitch and roll was exactly the kind of decision that got people killed. Formation pressures could change unexpectedly. The heave of the platform could affect the hydraulics of the mud column. Without the sensor data to identify early warning signs of a well control issue, the drilling crew would have no way they were in trouble until it was far too late to do anything about it. I told Marcus to find the documentation. I'd left him on the fiber optic network topology. I talked him through the most likely failure points for the trunk line, explaining that the storm conditions could have caused a junction box to take on water or a mechanical connection to work loose from the platform's movement. I stayed on the phone with him for over an hour while he traced the cable path through driving rain and gusting wind, and I felt completely helpless, knowing that I should have been there doing this work myself, instead of coaching someone through it from 200 miles away. At 12:53 in the morning, Marcus found the problem. A splice enclosure near the base of the derrick had been damaged, probably by debris flying across the deck during a particularly violent gust, and the fiber terminations inside had been compromised. He described what he was seeing, and I recognized immediately that this wasn't a quick repair. The enclosure itself was cracked. There was visible water intrusion, and at least 3 fiber strands had been physically severed. Proper repair would require cleaning the enclosure, preparing new fiber ends, fusion splicing the breaks, and testing the connections to verify signal integrity. Under normal conditions, with proper equipment and dry working environment, that repair would take a trained technician about 2 hours. Under current conditions, with a storm still battering the platform and only one semi-qualified person available to do the work, it would take much longer if it was even possible at all. I told Marcus to inform Carlos Mendez that drilling needed to stop immediately, that there was no safe way to continue operations without that sensor data, and that the repair would take a minimum of 4 to 6 hours. Marcus said he would relay the message, and I heard him put the phone down to go find the drilling superintendent. When he came back on the line, his voice had taken on a different quality, something harder and more defeated. Preston says we can't shut down drilling. He says the rig rate is $87,000 a day, and every hour of downtime comes out of his operational budget. He says Oceantech is working on a workaround to get the data through an alternate path, and we should continue at reduced parameters until they figure it out. I asked Marcus to put Preston on the phone. There was a pause, some muffled conversation I couldn't make out, and then Preston's voice came through with the same casual confidence I remembered from every interaction I'd ever had with him. Listen, I appreciate your concern, but you're no longer an employee of this company, and you really shouldn't be interfering with ongoing operations. Marcus can handle this. Oceantech is working the problem remotely. We have contingency procedures for exactly this kind of situation. I tried to explain to him, using the smallest words I could manage, that there was no workaround for the problem he was facing. The sensors that were offline were connected to that specific fiber trunk, because that was the only pathway with sufficient bandwidth and latency characteristics to support their data requirements. There was no alternate path. There was no remote solution. The physical damage had to be physically repaired, and until that happened, drilling operations were being conducted without safety critical monitoring equipment. I told him that what he was doing violated at least 4 different federal regulations and probably a dozen more provisions of the platform's operating permits. I told him that if something went wrong, and something absolutely would go wrong if he kept pushing, the consequences would be measured in human lives and environmental devastation and billions of dollars in liability that no amount of cost savings would ever offset. He actually laughed at me, a short, dismissive chuckle that communicated more clearly than words ever could that he thought I was exaggerating, that I was being dramatic, that I was a bitter former employee trying to sabotage the operational changes that had rendered me obsolete. Your concerns are noted, he said, using the exact same phrase he had used when I first warned him about Oceantech. Marcus will handle the repair. Oceantech will monitor the situation. We'll reassess at the morning briefing. The line went dead, and I sat there in my hotel room staring at my phone, knowing with absolute certainty that I had just witnessed the beginning of a disaster that could have been prevented at a dozen different decision points, every single one of which Preston Holcomb had ignored, because the numbers on his spreadsheet mattered more than the physics of what was happening 5 miles beneath the ocean floor. I called Marcus back and told him to start documenting everything. Every communication, every decision, every order he received. I told him to note the exact times and the exact words that were used. I told him that if things went bad, and I was now certain they would, he was going to need evidence that he had followed instructions from management against his own professional judgment. I told him to keep his phone on him at all times and to get to a lifeboat muster station at the first sign that well control was being lost. At 2:17 in the morning, Marcus called me again. His voice was shaking. The mud pumps just surged. We're seeing flow rate increases, but we can't verify them because the primary flow sensors are on the damaged trunk. The driller thinks we might be taking a kick, but he can't confirm it without the pressure data. Carlos is trying to get Preston to authorize shut-in procedures, but Preston is on a conference call with someone at corporate, and he's not responding. What do I do? I told Marcus to go directly to Carlos Mendez and tell him to shut in the well immediately, regardless of what Preston said, because Carlos was the drilling superintendent, and well control decisions were ultimately his responsibility under maritime and drilling regulations. I told him that if Preston tried to override a shut-in decision during an active well control situation, that was criminal negligence and Carlos would be legally justified in ignoring him. At 2:24, Marcus called to tell me they were shutting in. At 2:29, He called to tell me the shut-in pressure readings on the few remaining functional gauges were climbing faster than expected. 2:33. His call cut off mid-sentence, and when I tried to call back, I got nothing but a "subscriber not available" message. For the next 47 minutes, I sat in that hotel room not knowing if the people I had worked alongside for years were alive or dead. And there was absolutely nothing I could do about it.